All right, so I'm going to go over a couple of definitions in this video. It's more about kind of phrasing recognition than anything. Okay, so you're going to read problems, in the sciences and other places where you need to be able to interpret what they're trying to say. Okay, so the first thing that you will see a lot is something like this. Okay, so y varies directly with the nth power of x. It's equivalent to say that y is directly proportional to the nth power of x. And what that means is that y is equal to k times x to the power of n for some constant k, right? And the constant k is going to depend on the situation. All right, so press pause to make sure you get that definition down. All right, so here are a couple of examples. So the area of a circle, which we know is pi r squared, it varies directly with the square of the radius because there is some constant, in this case pi, there is some constant such that a equals pi times the square of the radius. All right, the volume of a sphere is another example of varying directly or being directly proportional to. So the volume of a sphere is directly proportional to, so usually the assumption would be if there's nothing that precedes the word proportional to, means it is directly proportional to. Okay, so this interpretation would be the volume of a sphere is directly proportional to the cube of its radius. And the reason is that the volume is some number times r cubed. So in this case, the constant is 4/3 pi. Right, so in general, that constant that you need to multiply to the power of your independent variable is called the constant of variation, or the variation constant, or constant of proportionality. Okay, you'll see various phrases used to describe that number. All right, let's get to my next definition. So y is said to vary inversely with the nth power of x. Or equivalently, we would say y is inversely proportional to the nth power of x if y equals k over x to the n. So inversely proportional to that power of x goes in the denominator, and the constant goes in the numerator for some constant k. So as an example of inverse variation, so the intensity of light will vary inversely with the squared distance from the light source. So I, being intensity, is equal to k over d squared is the mathematical equation that is the translation of these words. All right, so there's going to be some k, and in this case, the k will depend on the scenario. All right, so there are lots of examples in the sciences where you have this inverse variation, or varying inversely with something. All right, press pause and make sure you have that definition down. We're going to do a few examples using these. All right, let's do this example here. Suppose t varies directly with the square of p. Now also suppose that p is equal to 3 when t is equal to 10.8. We want to find out what t then will be when p is 1.5. So this is a classic type of problem that you first see when you're learning about variation. So the first step that we're going to do is we're going to actually write out the equation involving k. So you'll remember with direct variation, you have t equals k times your nth power. So we're talking about the square of p, so p squared. So that's the first step. All right, the next step is we want to find k using the given values. All right, so because if I tried to just directly plug in 1.5 for p here, then I'm still going to have a k left. So I need to find out what k is. So we'll plug in the 10.8 for t and the 3 for p. And then we find that k is 10.8 over 3 squared, which is 9, and that's equal to 1.2. All right, so now we know what our equation is. It's t is equal to 1.2 p squared. All right, so the last step is we're just going to substitute the given value to find the one that we desire. Right, so we'll substitute 1.5 for p in order to find t. So t is equal to 1.2 times 1.5 squared. And that is equal to 2.7. Okay, so that's the way you solve one of these problems. You set up your equation, use given values to find k, and then you go from there. All right, we're going to see another one. Okay, here's one for you. The intensity I talked about this a little while ago. The intensity I of light is inversely proportional to the square of the distance d from the source. When d is 3 meters, so 3 meters from the source, a 100 watt light bulb produces an intensity of 0.88 watts per meter squared. Find the intensity at a distance of 5 meters. Why don't you press pause and work on this? All right, so we set up our equation. T equals k over d squared, so inversely proportional. That power of your variable goes into the denominator. And as before, we're going to plug in the given information. Okay, so this here is not used actually in the equation. So it's the value of the intensity, 0.88, and the value of d, 3. So we have 0.88 equals, oops, I wrote t, I mean to write I. Hopefully you caught that. So I, the intensity, is k over d squared. So 0.88 equals k over 3 squared, which is 9. So that means that k is going to be 9 times 0.88. And you can just plug that into your calculator, and you get 7.92. Right, now we can answer the question. Find the intensity at a distance of 5 meters. So we know that the intensity is 7.92 over d squared. So at 5 meters, it would be 7.92 over 5 squared. And that is about 0.32. And our units would be the same as the units of intensity in the problem, watts per meter squared. Okay, so that's how you solve that problem. All right, we're going to do one more type of example. All right, why don't you read through this example, press pause, and work on it. All right, well, as always, we should start by writing out the equation that this is telling us. So this is telling us that y varies directly with means y equals k times x cubed for some k. And we're not given any information, so there's nothing that's going to allow us to actually find out what k equals. So now we should look, so what happens to y if x is halved? So what that looks like it wants us to do is, in place of x, put 1/2 x. So take our x coordinate and halve it and see what happens. All right, so now we have x, so that again means take the x and replace with half of it, and now we're cubing it. So we want to see what the end result was of this new quantity. So, well, this is going to be k times 1/2 cubed times x cubed. So that's k times 1/8 times x. So that will be, times x cubed. So that will be k x cubed divided by 8. So if y is halved, our answer is actually kx cubed over 8. So y is then divided by 1/8. is our answer. Right? So if they want you to, change x, that's all you do. You just change the x, and you see how your new quantity compares to your original quantity. Again, our new quantity was divided by 8 if you compare to the original, so 1/8 of the original value. All right, so that is it for this video.